Hi everyone. Good evening to everyone. Now we are going to study about the question number 64, that is gravitational potential energy. So it's all about gravitational potential energy. To understand that, the very first thing is what is gravitational potential energy of two point masses we need to understand. See, when you consider like there is one mass capital M and another mass at a distance r. So when you are bringing the mass m from infinity to this point, so you are bringing the mass from infinity to this point, then you have to do some work, external work, and that work done by gravity equal to negative of external work done. So that work done by gravity is nothing but negative of work done by gravity. Sorry, work done by external agent equal to negative of work done by. So that work is equal to change in gravitational potential energy. So as we are bringing from infinity, initial potential energy we will consider as 0 because at infinity there is no interaction. So that final potential energy will come minus gmm by r. Minus represents that there is always an attractive interaction between the masses, or gravitational force is always attractive in nature. So this is the gravitational potential energy of two point masses separated any small distance or greater distance, to small mass or greater mass, whatever it is. Now, when the question comes like when there are more masses are there, like if there is a system of masses, for a system of n point masses, for a system of n point masses, the gravitational potential energy is U1 plus U2 plus so on Un. N combinations will come. Combinations. So what are those combinations? Is n equal to n into n minus 1 by 2. Just like for example you consider there is a triangle having three masses at its three vertices m1, m2, m3. Then the total potential energy is, here combinations is 3 into 3 minus 1 by 2, nothing but 3 combinations. One is between 1 and 2, another is between 2 and 3, another is between 3 and 1. You should not repeat U311, U131, both are same. Like that, if there are 4 masses are there, like M1, M2, M3, M4, at 4 corners of rectangle or square, then the total energy is U between 1 and 2 plus 2 and 3 plus 3 and 4 plus 4 and 1 plus 1 and 3 plus 2 and 4. Because here 4 means 4 into 4 minus 1 by 2, that is 6 combinations will come. Like that, formula is same again G M1 M2 by R only, but the number of combinations are more because for one system of 2 point particles, the energy is G M1 M2 by R. So based on this simple concept, you can understand how to solve the questions. But sometimes they will also ask the work done. The question can be asked like what is the work done in changing the configuration. Work done nothing but as we discussed the change in potential energy. So let's see based on this simple thing how the questions they are asking. So the very first thing is 2 point masses 1 kg and 4 kg are separated by a distance of 10 centimeter. Find gravitational energy of the 2 point masses. So the gravitational potential energy means G m1 m2 by R equal to 6.67 into 10 power minus 11 into m1 is 1 kg, m2 is 4 kg by 10 into distance centimeter means 10 power minus 2. So this way you can understand the simple questions. Now, next question. Three particles of masses are placed at corners of an equilateral triangle. So now the question is about equilateral triangle. Now three masses, one is m, another one is 2m and another one is 4m are placed at corners of triangle, equilateral triangle. Side length is how much? A. Now the potential energy of the system. As three combinations, three particles are there, three combinations will come. Like 1, 2, 2, 3, 3, 1. Let's take like 1, 2, 3. This is 4m. Now, between 1 and 2 means Gm 2m by A. Between 2 and 3, G 2m 4m by A. Between 3 and 1, G into 4m into m into divided by A. If you add all them, then you will get the total potential energy. But one more question they asked in the same thing. The work done on the system if the side of the triangle is changed from A to 2A. Now the thing is, see, initially the side length is A. Now you are moving the particles apart such that now the side length should become 2A. That means there is some initial total potential energy. Again the combination will come same thing, U12, U23 plus U31. But with a separation A, like same what we calculated. Now there is one final potential energy, that is again U12, U23 plus U31. Same thing, but instead of A, 2A will come here. So that work done will become now final minus initial. Change in potential energy is nothing but work done. As I said, sometimes the question can be asked based on work done in changing the configuration, but work done in changing the configuration nothing but change in potential energy. So that way, if you calculate both of them and subtract, then you will get the answer. Now, the next thing is infinite number of bodies, each of mass situated on the, what is the result in gravitational potential? See here. So gravitational potential at a point equal to work done in bringing from infinity to a distance per unit mass. So due to a point mass at any distance, the gravitational potential is minus Gm by R. See, that's why there are similarities between electric field and magnetic field, electrostatics and gravitation. Same formula, similar formulas will come. Now there are, how many masses are there? Infinite number of masses. All are of same mass. Now at the origin we have to find the effective gravitational potential. Like this is x-axis. Now this is origin. Now there is one mass at a distance 1 meter and there is another mass at a distance 2 meter. Then another is at 4, another is at 8, so on. Now the total gravitational potential means V1 plus V2 plus so on up to infinity, because it is a scalar quantity, like minus Gm by 1, minus Gm by 2, minus Gm by 4, minus Gm by 8, so on. Now when you consider minus Gm common, 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 up to infinity. Now if you look at this series, it is Gp, infinite Gp, like A plus AR square so on up to infinity, where common factor is 1 by 2. So the sum will become A, first number, first digit, by 1 minus R is common factor. So you will get the answer minus 2Gm, where M is 2 mass, 2 kg. So answer will become what? Minus 4G. So this way, sometimes the question can be asked based on the gravitational potential. And if they ask the question based on gravitational potential due to system of point charges, system of point masses, then just like here what we have done, You have to add it because you are not just for one mass. There are so many masses. That is only called what? System of point masses. Then you have to just take the simple scalar addition because the potential is a scalar quantity. Now one more question. The mass of earth is, so mass of earth is 6 into 10 power 24 kg. The gravitational constant they have given. Okay. Then the potential energy of the earth and moon system is, so there is earth and there is moon. Now you, as they are big particles, you will consider the distance as distance between their center of masses. Now the potential energy of the system is minus 7.79 into 10 power 23 joules. Then determine the mean distance between earth and moon. So potential energy equal to minus GME. This is mass of moon, mm you consider, divided by R. Now R will become what? Minus GME by U. All values they have given. So G is given, ME is given. Oh, but here in the question they have to give one more data, that is I think missing. Mass of the moon also needed. So let it be. So if the data is given, then you can just substitute and solve it. So it's a direct question only. So as data is missing, let it be. You can take something and you just do it. Just calculation for the practice purpose. But the meaning of the question is, when they have given the gravitational potential energy of two masses, two big particles, the mean distance is nothing but the distance between their center of masses. Then accordingly, you can take the same formula. Now, one more question. Find the change in gravitational potential energy when a body of mass m is raised to a height nr above the surface of Earth. Now, on the surface of Earth, when you consider if there is a Earth of mass m, radius is r, and when you place one mass on its surface, now the distance between mass and Earth will become r. Because distances you have to measure from the center of Earth. That is nothing but center of mass. So that the initial gravitational potential energy is minus gmm by r. Now what you have done is you have taken the object to a height, some height h equal to nr. Now the final distance will become r equal to r plus nr. Now the final potential energy will become minus gmm by r plus nr. Now they are asking find the change in gravitational potential energy. Change means final minus initial. So final means minus gmm by r if you take common 1 plus n. Minus of minus gmm by r. So minus of minus it will become plus. Now if you take gmm by r as common, 1 minus 1 by 1 plus n. So that it will become what? gmm by r into n by 1 plus n. So this is the gravitational change in gravitational potential energy. When you change the configuration of one mass or when you change the position of particle from the surface to any particular height. So this is how using that formula you can find the gravitational potential energy or work done based questions. So try to understand, and similar questions I have given as an assignment. So just try to understand. So we'll continue in the next session with the next class. Thank you.